Let's build a real simple circuit and show the proper way to measure current and voltage. We always start our projects off by using this A module. This is going to give us a fuse, and it's called best practices. You should always come in off your power, go through a fuse, therefore protect the rest of the circuit. So we use this on all projects as our to start off the whole project. Drop in a marker light here, simple one light. We'll come through a fuse, through a switch here. And into the light. And we'll complete a circuit to ground. So this is a complete circuit. It could be considered a series circuit because there's only one path for current to flow. And we have a working circuit. Now, I can check the current in the circuit, and I can check the voltage on the circuit. So let's start by checking the current. Now, to check current, the meter has to go in series with and become part of the circuit. It's also important to realize that I've got to do that because I've got to, this will not control current. A meter set up as an ammeter has no internal resistance. So for amps, I'm going to go amp here, and we'll use your COM port and the amp port. And I need to open the circuit up, so actually we'll just pull this back out. So we'll take this circuit. Now we can do it anywhere in the circuit in this case because this is series, and anywhere in the circuit to open it up. You see first of all that the load stopped, the light went out because we have an open circuit now, it's not complete. But now I can come into the meter. Just come in through the amp port, and I have to come back out of the meter, just come back out through the COM port and complete the circuit. And we see we see the light came back on. This ammeter is not going to affect the current. It's going to just measure the current. Now current flows through the fuse, through the switch, into the amp port, back out the COM port, and on the ground. The bulb is working fine. If we want to see the actual current going through the bulb, we see a 260. The leading zero is insignificant, drop that off. The 260 what? It's 260, I'm not sure if you can see this on video, a small m and large a. That's 260 milliamps, or 0.26 amps, a quarter of an amp, 260 milliamps. This is the way we do that. Now, what would have been an improper way to do this, which is a very common mistake of those, is go back to our circuit. And often I'll tell a student to hook into the circuit to measure current. And so they go to the current mode here and here. They'll go to the amp port, the COM port, they get all, and I'll say measure the current through that bulb. Then they'll come in here and get ready to take on a parallel relationship, which when you tap across here, which I won't do, matter of fact, let me turn off the circuit here. When you go across here, first of all, that's not the correct way to do it. This is called a parallel relationship, that we've tapped onto a circuit from the side and gave it a parallel path for current flow. Now, what's going to happen here is positive, this is 12 volt DC, current can now flow through the fuse, through the switch to here, then right through the meter, which remember is in the ammeter mode is the characteristic of a wire, a solid conductor, right to ground. So I've created a path from power to ground with no resistance. And as you all know, resistance controls the current flow in the circuit. So we've created a situation where it's going to be technically unlimited current. What's going to happen, the current ramps up. We either blow this fuse, but more likely you're going to blow a $8 meter fuse, and it's going to take 15 minutes to change it out. This is the incorrect way to measure current. It's a very common mistake. You have to recognize when you check current, it goes in series. Now, if I were to want to check voltage across the bulb, this would be the correct way to hook up. I've got to prepare my meter to measure voltage. So I'm going to come over from the amp port back to the volt port, leave my COM port there, come back to volts DC, and then go back live And now we'll actually see the voltage applied across that bulb, which is 13.8, the big V, no multiplier, so that's 13.8 volts. In most cases, this voltage should be the same voltage applied across the circuit. If it's different, and we can see that, that's 13.8. Let's take a peek at source voltage. And 13.83. So what's going on is 0.03 of a volt is dropped, either getting to the bulb or getting back to ground. That's an insignificant amount, but you'll see as you go through this course that that's a very effective way to look for resistance in the circuit. If you check source voltage, and then check voltage across the load, and there's a significant difference, that means that we're dropping voltage either on the plus side or power side or on the ground side. And when that happens, we need to track that down through pinpoint tests, doing voltage drop checks, and find out where the voltage is being dropped. When you see voltage on a circuit with current flowing, that means that there is resistance in that section, because voltage or voltage drop is produced when current flows through resistance. So if you see a voltmeter reading on the circuit away from the load, that's not a good thing. It depends on the circuit, how much you can tolerate. If it's starter draw and you're pulling 300 amps out of the if you're pulling 300 amps out of the battery on starting, you can tolerate some voltage drop. If it's a computer control circuit, very little voltage drop is tolerable. So that's a wrap now for the proper use of a meter.